welcome to Two Projects. In this video, we are going to explain the project Face Attendance System using Machine Learning and Deep Learning. Introduction. The Face Attendance System utilizing machine learning and deep learning techniques is an innovative solution designed to automate and streamline the process of attendance tracking. By leveraging advancements in artificial intelligence, this system aims to accurately recognize and record attendance through facial recognition technology. Traditional methods of attendance tracking, such as manual entry or swipe cards, are prone to errors and can be time consuming. The face attendance system offers a more efficient and reliable alternative, eliminating the need for manual input and reducing administrative overhead. Additionally, it enhances security measures by ensuring that only authorized individuals can access designated areas. So, this system caters to a wide range of sectors, including educational institutions, corporate offices, and organizations with large workforce management needs. Students, teachers, employees, and administrators stand to benefit from the simplified attendance management process, allowing them to focus more on productive tasks rather than administrative chores. And machine learning, deep learning algorithms play pivotal roles in the functionality of the face attendance system. These technologies enable the system to learn and adapt to different facial features and variations, ensuring accurate identification even in varying lighting conditions or angles. By continuously refining their models through training on large datasets, the system can achieve high levels of precision and reliability in attendance tracking, thereby enhancing overall efficiency and convenience for users. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to develop a robust system capable of automating attendance tracking processes. By leveraging machine learning and deep learning techniques, the project aims to create a reliable solution that minimizes manual efforts and errors associated with traditional attendance recording methods. And the objective is to evaluate and compare the performance of k nearest neighbors, support vector machines, and convolutional neural networks for facial recognition in an attendance tracking system. This involves assessing metrics such as accuracy, precision, recall, and F1 score to determine the most effective model. And the project seeks to enhance the efficiency and accuracy of attendance management systems by implementing advanced facial recognition technology. By accurately identifying individuals in real time, the system aims to streamline attendance tracking processes, thereby saving time and resources for both administrators and users. Another key objective is to ensure seamless integration of the developed solution into various environments such as educational institutions, corporate offices, and organizations with workforce management needs. By providing a user friendly interface and adaptable architecture, the project aims to facilitate easy deployment and widespread adoption of the automated attendance tracking system. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is import and required packages. Here, essential libraries such as NumPy, Pandas, sklearn, TensorFlow, Keras, Matplotlib, and OpenCV are imported to facilitate data manipulation, machine learning, deep learning, and visualization tasks within the project. The second step is exploring the dataset. In this step, image metadata is structured, allowing efficient organization and access to image data from specified directories, facilitating subsequent data pre-processing steps. The third step is data processing. Here, images are loaded using OpenCV, aligned via facial landmarks with OpenFace alignment utility, ensuring uniformity and suitability for subsequent training procedures. The next step is train and test split. In this step, the dataset is partitioned into separate training and testing sets to enable robust evaluation of model performance, aiding in preventing overfitting and ensuring generalizability of trained models. The next one is training and building the models. Here, KNN, SVM, and CNN models are trained using pre processed data to recognize facial features and predict individual identities, leveraging machine learning and deep learning techniques effectively. The next step is performance comparison. So, model performance is meticulously evaluated using accuracy, precision, recall, and F1 score metrics, enabling comprehensive comparison to ascertain the most effective model for the given task. And in the next step, a user friendly interface is developed using Flask, incorporating features for admin authentication through SQLite, enhancing usability and security for system access and management. So, administrators are empowered to add users, register their facial features, and manage personalized attendance tracking, fostering adaptability and customization within the system. Leveraging facial recognition technology, the system tracks attendance efficiently, offering a modernized solution that streamlines the process and mitigates the shortcomings of traditional methods, ensuring accuracy and convenience. Now we'll understand about the algorithms used. So first we'll understand about OpenCV. It is a powerful open source library designed for computer vision tasks and image processing tasks. It provides a wide range of functions and algorithms for tasks such as object detection, image segmentation, and feature extraction. In this project, OpenCV is utilized for its robust capabilities in processing facial images, extracting relevant features, and preparing them as input for recognition models like SVM, KNN, and CNN. Its versatility and efficiency make it an ideal choice for handling complex image processing tasks, ensuring accurate and reliable face recognition in real world scenarios. So, the first algorithm built is Support Vector Machine, that is SVM. It is a powerful supervised learning algorithm used for classification tasks, including facial recognition. SVM works by finding the optimal hyperplane that best separates different classes of data points in a high dimensional space. It maximizes the margin between classes, effectively reducing the risk of misclassification and improving generalization performance. In this project, SVM is suitable for facial recognition because it can efficiently handle high dimensional feature vectors extracted from facial images, making it effective in distinguishing between different individuals based on facial characteristics. The next algorithm built is KNN, that is K nearest neighbors. So it is a straightforward algorithm for classification, including face recognition. It works by finding the closest data points in the feature space and assigns the input face to the class that is most common among its nearest neighbors. KNN is suitable for this project due to its simplicity, computational efficiency, and robustness to noise, making it effective for small to medium sized datasets and varying facial expressions and lighting conditions. And the next one is convolutional neural networks, that is CNN. So, CNNs are specialized deep learning models ideal for processing grid like data such as images. They utilize layers of convolutional filters to extract hierarchical features, allowing them to effectively capture patterns and spatial relationships within images. Due to their ability to learn complex representations directly from raw pixel data, CNNs are well suited for tasks like facial recognition, making them a perfect choice for this project. Now we'll see the comparison graphs. So this is the bar graph comparing accuracy scores of different algorithms. In this graph on x-axis I have algorithm names and on y-axis I have accuracy scores. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have algorithm names and on y-axis I have precision scores. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have algorithm names and on y-axis I have recall scores. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have algorithm names and on y-axis I have F1 scores. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions, and we can see SVM is doing well. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is attendance folder in which student details whose attendance has been recorded will be stored. This is images folder in which I have images on which we have trained the models. This is models folder in which I have model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is a model file again. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file Explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a login link, click on it. So here we have to give our credentials, username and password to login. And if you are new users to the system, we have to register. First, click on sign up link, give the details and register. As I'm already a member, I'm directly signing in. So give the username and password here and click on login. It has redirected us to the attendance page. So here, administrators can enroll new users or students into the system by providing the username and ID. Additionally, facial recognition is required for identification purposes. So username would be Swati and user ID would be 25. Now click on add new user button. So present your face here to the system to acquire its features from all the angles and expressions. So the system will stop learning after acquiring 50 features automatically. Now we'll take the attendance, click on take attendance link. We have to show our face again for recognition. Once a registered face is detected, the application will draw a bounding box around the detected face and it will display a name with ID. So to take attendance, admin have to click on A button. We can see the attendance has been marked. We can see the serial number, name, ID and time. So we can see list of student details who have been marked as present here. Similarly, the admin can create any number of new users and conduct attendance using face recognition. So the conclusion here is the project successfully developed a robust face attendance system leveraging machine learning and deep learning techniques, automating attendance tracking processes and enhancing efficiency. Through rigorous evaluation and comparison of KNN, SVM, and CNN models, we identified the most effective model for accurate facial recognition and attendance tracking. SVM has outperformed other models, so we deployed it in Flask. The implementation of a Flask-based front-end and user management functionalities ensures ease of use and seamless integration into various environments, enhancing accessibility for administrators and users. By incorporating advanced facial recognition technology, the system improves security measures and reduces the likelihood of errors associated with manual attendance recording methods. And moving forward, ongoing advancements in machine learning and deep learning can further refine the system's capabilities, potentially expanding its applicability and enhancing its performance in real world scenarios.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.